Hello everyone. Well, thanks for coming. Thanks for surviving. Who was to the party yesterday? Who played any sort of games in there? At least half. Well, smaller half of the room, I would say. So Golang. So the language is called Go, as you might probably have heard already. If you want to Google it, use the term Golang. But if you try to Google for Go, it will not work. Has anybody tried Go before? I can see a few hands. Well, I would be really thrilled if after this presentation you actually gave it a shot. It's really easy, really fun, and very concise, much faster than Java, no Maven included. As you can see, there is another conference logo. You could be curious, well, what is Atmosphere? Atmosphere is basically a DevOps conference that's also organized by PROIDEA. I've been there, I've given this very same talk there, and it's quite an awesome conference if you're into subjects that Tomek Borek presented, I believe, an hour ago. This is a place for you for sure. So, a bit about me. I have a Twitter, yay, I have an email, I have a blog which is not very active, but I have it. And I work in eBay. And you might be curious, where is eBay in Poland? And the reality is I don't really live in Poland, I live in London. There is an eBay office in London, there is an eBay office in Zurich and in Berlin. If you're interested in relocating and joining eBay, well, talk to me after. Of course, eBay is recruiting. Few things about me. I lead the Polish Java user group. I organize a conference called Geekon. You might have heard of it. I also used to run Software Craftsmanship Kraków, and I used to run the Kraków Hadoop user group. As I said, used to, because London, Kraków, well, not really the same thing. If you would try to describe if I would try to describe who I am, I would say that I started as a developer. I still am a developer, but I'm always curious what happens one layer under the skin of what I'm currently doing. So if I'm doing Java, I'm probably, I started being curious about, okay, how is it that the JVM actually works? Then, okay, what happens on the what happens deeper and deeper and deeper? And then I started, exploring sysadmin kind of reality. And then, of course, you have to do a bit of C there. And then I found this nice little language that is a very good replacement for C. That is called Go. A few disclaimers. First of all, my opinions are my own. I'm not representing any organizations. I sometimes say I hate computers, and if you know me any bit, you know that I like complaining. And if you have any questions, guys, just shoot. I hope that you can see those two tokens of gratitude for questions. I have 3 of them. The first 3 questions will, of course, get them. So I'll be very happy to just wave your hand and grab a mic or try to scream. I'll try to repeat the question if I hear it. Golang. This is how you Google it. So let's start with an inspirational quote. I have no idea where it comes from, of course. So Golang, Gopher. Golang is connected to gophers as, I would say, Java connected to beans. Gopher is the official Golang mascot, so you have to know it. You just have to know it. It will happen on all the websites, and basically that's it. It's free and it's open source. It's licensed with a BSD license, so it's not GPL. So you're probably safe to use it at your workplaces. I'm saying probably because different corporations have different fun requirements sometimes. But for example, at eBay, Go is being used in production. Also, if your organization is playing with Docker, Docker has been written in Go, and there is a bazillion of other tools that have been written in Go because it's such a cool and nice and very performant language. It comes from the big G, but as I said, it's open source, and there are people on the internet contributing to it, not only from Google. So if you're very curious, if you'd like to contribute or start writing libraries, well, feel free. It's also extremely fast, and I mean really fast. If you remember CFast, or if you think CFast, well, Go is CFast. If you're a bit tired, which you might be, since most of you attended the party, short description or short story about Go is, well, basically C++ and Ruby mixed together. Take the nice elements from both, and voila, you have Go. So play it with tonight, download, well, write at least a hello world and maybe do some WebSockets. It's really trivial and it's a lot of fun. Why do I like Go? So well, this talk will not give you the basics to the language. I'm not going to tell you how all the loops, all the basic constructs work. Sorry, that you can Google that. Or you can talk yourself out of doing any work to do that, or you can do something else. I strongly believe since you made it to here, you are very able to follow tutorials, so there is no point. Why do I like Go? Good parts. Me not complaining, that's quite odd. First of all, what you get when you compile a Go program, you get no runtime dependencies. Everything is statically linked, you get a large binary, it can be a few megabytes. But then if you want to deploy a few megabytes, well, jar hell, what is that? Maven? Why? Dependencies? This is the binary, you just put it out there and you run it, and that's it. So from a well, deployment perspective, it's awesome. From a well, runtime perspective, it's awesome. From a developer's perspective, it's pretty awesome as well. And it comes from C. There is a lot of similarities between Go and C, but it's much more pleasant. There are pointers, yes, and you can hurt yourself. Yes, you can shoot yourself with into a foot. You can have a seg fault. Yes. But Go compiler will go to great lengths to prevent you from doing that. And it's actually quite restrictive in what bad things or what smells it allows. So, Go. Nice things. Well, the first nice thing about, well, the most nice thing, the biggest problem with Java, we've got Gradle, which is awesome. We've got Maven, who everybody loves. We've got Ant with Ivy. We've got SBT. Yeah, with Go, you have one command. It's called Go. And if you want to compile a program, you do Go build. If you want to clean, you do Go clean. If you want to, well, if you want to run it, you just execute the binary that comes out of that. So let's try to change into a console and see what happens. So if I type Go, you get that. And I have a tiny bit there. That's irrelevant. As you can see, well, it already gives you some commands which can do some of things that are, well, pretty common. I'm particularly fond of this one. Go, well, FMT. It runs Go FMT. What is Go FMT? Well, it's that doesn't matter. But I can do that. Well, I should be able to do that, or I should be able to do, of course. Anyway, Go solves a very important problem right in the beginning. For some people, this is the most important problem in all computing. There is only one formatting. It's defined in the language. Go FMT will format your sources accordingly. So if you're fond of fighting tabs versus spaces, this problem is not really needed. It doesn't exist in Go. There is only one true formatting. It might not be that because my presentation software might have misdisplayed a few items, but all programs in Go look the same, which means check style, problem solved, not needed. And also types. It's not going to be an introductory to the language. I'm not going to tell you the ranges or the things, but as you can see something interesting when it comes to ints or unsigned ints or floats or, well, complex numbers. You can see those, well, numbers coming after the type, which means if you see a uint 8, you know how wide it is. And it's always 8 bytes wide, and that's it. There is no other way. So it's pretty explicit. And if you're defining APIs, and if you're doing that on multiple systems with, let's say, different endianness, that helps. Of course, endianness is not defined in that. That doesn't come for free. But at least if you know the width, and if some organizations still use 32-bit software, and some are now on 64, but sometimes not fully, it helps. Because if it's 64, then it's 64. If it's an int, and you're changing, well, one version of, well, recompiling C code from one machine to the other, you might get surprises. In here, that's avoided. So let's take a look at a sample program. That's what it looks like. You can define a variable, and then you can assign to it, or you can use this awesome Pascal-like operator to define and initialize a variable, and you can use something to print something, or, well, you can use that to print the length of the string. Which means string is not a class. Oh well, that's not such a huge pain. So let's do the mandatory hello world. I assume this is large enough. So go build, what's it called? That's called main. And I'm trying to compile it, and the compiler complained that I'm importing and not using time. And yes, there is, well, the time package is being imported, and I'm not using that. So the compiler will actually complain, and it will tell me, well, go fix your source. I'm not going to allow laziness, which is awesome. Unused code, unnecessary code, not allowed. You're free to comment it out, but you're not going to have unused variables. That's pretty awesome. If you know large code bases with Mount Everests or multiple Mount Everests, and you probably know how many unused things there are in the source. Well, in source trees like that, in Go the problem doesn't exist. Just that. So we've built it. Question is, what do we get? We get this main thing, and you can see that it's quite big. Yes, it's over a meg for a hello world, but as I said, this doesn't have any external dependencies, which means I can just run it, and I can run it elsewhere, and I can copy it to a system, and it will work the same. And it has a lot of UTF because Go is UTF by default, so it has a lot of UTF symbols in there. That's where majority of the size comes from. So moving on. You of course need to have some sort of maps. What do maps look like? You define a map like this, a map that maps from string to bool. This is how you initialize it. Pretty well simple. You can print, well, this is how you access something that exists in there, and now you can see something interesting. There is no entry of AGS in this map, which means what should you get? You could expect a null, you could expect an error. What you get in Go, what the convention is in Go, is you get the 0 element of a data type, which means, well, for bool that's false. And then of course, if you assign it to true, you can, well, see that then I would get true there. Can anybody spot anything odd in here? There is an actual mistake in this code, or something that comes out of nowhere. Yes, congrats. You need to get yourself an opener, but congrats, enjoy. Moving on, structs. I said it's inspired, so we get structs. This is, well, a struct. A struct is an encapsulation of fields. That's it. You can assign, well, you can have methods or functions that work on structs, but they are not part of they will not be a part of a struct definition. How you define it? That's easy. They can go in the order they appear, or you can use named parameters. If you've ever wondered, if you've ever seen a 40-parameter constructor or a 40-parameter method invocation or type definition, well, I'm not recommending doing such monstrosities in here, but the fact that you can actually name your parameters and make the code more explicit, well, I at least love it. So we have defined a rectangle, and we can call, I'm doing something that doesn't exist yet, so that we'll go a bit further. How do you define a method or a function that works on a type? Like that. So we have a struct called square. We have a function that expects a square. That is called area, and as you can see, it's with a capital letter. So if you're from the .NET kind of world, you're familiar. If you're from the Java land, they just went with calling functions with starting calling functions with a capital letter. A convention, yeah, but well, that's how it is. And then you just do a return. So you can do something like this. You define a square, and then you can call it. You can call this function on this type, like if it was part of the definition, but it's not really in there, which I find quite interesting, because then your data definition is being separate from your, well, behavior. You can say that it's not really well object-oriented, but I don't know what about you, but I very infrequently see code that is first properly object-oriented, and when it comes to expressing business scenarios, code actually looks pretty well. I'm short for word. Structural. Yeah, so structures, you get structs and then you get, well, behavior placed somewhere else. Is it a problem? I thought it would be, but it's actually okay. You probably would put both in the same in the same file anyway, but you can do that. Let's see if it works. Because of course you can, I could be lying. So we need this guy, we need that guy, and we need this, and we will also need here. So what's in here? Well, we have a type of square, we have a type of a rectangle, nothing really fancy. We have a square, an area function that will operate on a square, and we have an has area interface. So wow, we have interfaces, and has an interface in Go is basically something implements an interface if it has all the methods, if it implements all the methods available for that interface. That's it. It's not defined anywhere else. It's purely, well, can you do all that the interface promises? If you can, you are of that interface. So that's pretty obvious. We can call area on a square, and we can have a rectangle, and we can define it in two ways, and that's all the things that you have seen already. And you can print it. Let's see how a struct prints. So go clean. Oops, undefined rectangle. How come? Because I didn't save, of course. So this is how a struct prints itself. Unfortunately, without parameters, that's basically a default toString. But it works. That's what we were interested. And what we have in here, we're calling the dot area through an interface on an object, well, on a struct that is, well, actually here it's a square. If we would try to do that with something that doesn't work, well, compiler would complain and it would tell us that, sorry, well, that's not really possible. Which means compiler will protect us there as well. Let's move on. Let's get into the fun bits. Interfaces. We just slightly covered. If basically you implement an interface if you have all the methods. So if there is a method for a type defined that matches this signature, so something that is called area and it returns an int32, you implement that interface. If you don't, then it is not. End of story. Moving into really interesting bits. Go routines, lightweight threads, or what interesting can you do with Go functions? There is a short program that, well, I think that the first bit is quite self-explanatory. What it does in here, well, what is new in here is this Go bit. So you say Go function with an argument. If you wouldn't invoke function with if you would just do f of argument, that would be a normal function invocation. If you do Go function, well, you will invoke it, but not in the current thread. It's going to be executed somewhere else. From your point of view, you can think of passing that to an executor service, or basically something like that. What isn't important that if you have many threads, many cores, you can have parallel execution like that. There are no explicit threads available to you in Go. You don't have to start a thread, you don't have to implement a runnable. You just say Go function, and the function will be executed somewhere else, just like that. So let's run it, because there is something interesting that I, of course, haven't told you yet. We need this, and we need that. Oh. Of course, runtime is imported but not used. Let's be better. Yeah, I told you that it would be executed in parallel, and that's doesn't really look that parallel. What's wrong? Well, the thing is, Go by default only uses a single thread. You can redefine that and tell it how many functions, how many Go routines it should execute at a single time. You can either pass it through an environment variable, or you can change the runtime Go max procs parameter. And well, if we change that, so go clean, go main. Well, it's probably a bit. It might not be easiest to tell, but now it's they should be executed in parallel. Let's move further. We will see that better in a second. As I said, how many Go routines will run? Go max procs. Why am I telling you about this? Because I was surprised when I discovered that it defaults to only one. What can you do with functions? You can, well, you need to synchronize them somehow. So if you have many functions running on multiple threads, how do you communicate from one to the other? That's in Java. Well, of course, you use synchronize, you use notify, and soon after that, you start to hate yourself and the world. In Go, you use channels. Their goal is to communicate, to provide a means of communication between functions. They have type, and they are thread safe. You don't need to do anything like synchronize. You don't need to play special tricks with volatiles. You don't need to put a lot of the unnecessary clutter that Java sometimes requires. How do you make a channel? Channel. You make a channel which has a type of int, and that's it. Actually, what this is an unbuffered channel. So it is synchronous and will wait when it's empty, and it's unbuffered, so it doesn't have a size. So you can put as many things as your memory permits into that, and then you can read as many as there are. You can also do something that's called buffered channels, that is exactly like a channel but has a specified size. As you can imagine, if you specify the type and if you specify the size, you will get a continuous bit of memory reserved somewhere, and that's basically what happens. They are async. They will return a 0 when they are empty. So a 0 element for Boolean is false, for int it's 0, and so on. And they will wait when you try to insert something into them, and they are full. Why is it useful? Well, we'll soon see. Basic syntax for talking to channels: putting something into a channel, reading from a channel into void, basically to see if just get anything out of there, assigning to a variable, and that's a new thing. So what is this OK thing here? This OK thing, it's an error code, because in Go there are no exceptions. So you don't have to do throw catch. You don't try catch. You don't have to throw. You will not throw. But for every return, you can actually return also, apart from the actual value, you can return an error code. And if you look at the APIs, if you look at the libraries, if you look at what's available, all of the I/O operations will return an error code. And it's usually up to you to react to it somehow. In many cases, you can ignore it, but well, you know what it will lead to. This is an example of how you communicate between two funcs. It needs a channel, which is called connection. You put a random integer in there, then you read it, and then you print that you actually have received that. Quite self-explanatory, but doesn't look interesting. And I promise you that there will be something interesting. So one quite cool thing that you can do with functions and Go routines and channels is you can coordinate them So what happens in here? You make a channel, and then you do a function, and you can close it or write anything into that. And in the other function, you can actually try to read from that channel. So imagine there is a lot of, well, busy I/O happening over here. What this will do, well, that function, when it tries to read, it will wait, and it will wait, and it will wait until you close the channel. As soon as you close the channel, this can proceed. In Java, that would be, I don't know how many lines, but let's assume, well, 15. And that's it. Synchronized, not needed. Notify, not needed, and no sleeps, no latches, no barriers. That's everything that you need. Already, thread safe already works out of the box. I like it. I like it quite a lot. And when you have to synchronize a few functions, that actually how little you can, with how little code you can achieve a lot. Do you know latches in from Java util concurrent? Yes, no, or some people do. Basically, you know, you probably have seen a horse race, at least on TV. So you know the starting bit where all the horses enter those funny gates. That's how I imagine. That's what I usually use to describe a latch. All the threads have to go into a certain place, and when they are all there, they can start or they can proceed. So you make a latch. So you make a channel. You fire off the worker, let it go somewhere, let it run. And then, well, it does all of its I/O, and then it appears up to the, well, then it appears at the latch, and then it will block. Imagine you have many threads, many functions actually waiting for that moment, waiting at some condition to change. You can actually let them all go with a single close. To me, that's pretty neat. To me, that's pretty amazing. I find it, well, really concise, and I find it a really powerful construct. Do you find it nice? Yes, no? Would you prefer to do it in Java? I've heard a no, but a very silent one. You can still get a beer. Enjoy. Generators. What are those? Oh, wow. You probably have heard of sequences in a database, a source of numbers, or you probably have heard of streams in Java 8. If you want to get numbers, or if you need to, well, get subsequent primes and make it make something that will produce those primes for you, something that is accessible from multiple threads so that the numbers will not be repeated. Again, in Java, that would be probably ugly. In here, generating sequential numbers accessible only from a single thread, that's the whole thing. You just keep querying, you just keep getting things from this ID channel, and then the magic is, this is where the magic happens. You only, this will only get executed when you actually read from the channel. Which means you don't have to pre-allocate a lot of values. You don't have to worry about, well, things being inefficient or suboptimal. This will only create one, and then wait for you to read that, and so on, and so on, and so on. And again, because it's channels, and channels in Go are completely thread safe, you actually, well, you're covered. You can use it from well, wherever you want, and this will work, which is awesome. And you can also do multiple channels at once. What happens when you try to read from 3 channels at the same time? There is this nice construct that allows you to do a select, which means I want a value out of any of those 3 things, and I'm interested in the first one that appears. So you can actually try to read from one of the 3 channels all at once. Doing that in our favorite programming language started with a J. I have no idea how many lines that would be. And I have no idea about how many backing up code there would have to happen so that you could have something as nice. In here, it's already built into the language. That's it. So, Channels, nice. Well, types, nice. I only have 15 minutes, but I should be fine. Let's say we have a channel, then we close it. So we have some values, but think of it as an array or something like that. We ask the go routine that fills in the channel to happen. It runs, it's there. Now we want to read from that channel elsewhere. How do you iterate? Well, this is how you iterate. You have to define a range and get things from the channel. Is it useful? Yes. Why? Because with ranges, you can actually treat arrays and channels in a very similar manner. Well, the language construct is exactly the same, which means that what a good metaphor, what a good illustration for channel is basically a synchronized array that sits somewhere in memory. Remember, it can have a specific size, or it can be undefined in size, but it's basically an array that's safe to share across functions, and it's provided by the language, provided by the runtime, all there just to be used. Packages, because well, code has to happen. You have to ship your code somehow, and you sometimes depend on somebody else's code. Let's go into the console for a moment. Let's clean again. Notifications, sorry for that. And as you can see in here, I have this funny little guy. I'm importing something from the internet. And yes, that's wrong that I actually depend in my code on the internet, but for the time being, let's proceed. Sorry, go clean and clear, and then go build. Do I have internet? Go install. Why? Go get. Oh, silly me. I type in go get. Main is the package name. Now, what happens? I have a lot more of source code in here, which means this is Go's equivalent of Maven. First of all, it's built in. Second of all, it will compile the code on your machine. Third of all, I'm saying it will compile the code. So if you are curious what the code of your library is, it gets downloaded there. There is a caveat, of course. Because the code comes from the internet, it means if somebody changes the code on the internet, you're at a risk. Which means that you probably should only import from repositories or from branches or from places you basically can trust, and you probably should have your own internal repository for code. But I find that pretty neat. I don't know how many times you've had Maven or something else fail to download sources for a library, and then you had to decompile, and it was kind of matching what you were running, but not really. But the problem doesn't exist in here. You just get the code. Of course, if you want to ship just the binaries, not the code, that will lead to a tiny problem. But assuming you're working with code most of the time and you want to depend on a library, it's awesome. It saves your time, saves your nerves, and boosts at least my productivity quite a lot. Go get, well, if you have multiple packages in your project, and that's all built into the language already there. Net or network. If you want to do an echo server, how do you do that in Go? Looks pretty simple. And now what's the caveat in here? Let me show it to you, because that will be an interesting bit. No. Oh no, it says concurrent, but do I have a non-concurrent? Yes, I have a non-concurrent. Pretend to close your eyes. Or now it's not needed anymore. Go build main. What is the port? 4000. And that's broken. What's wrong? Oh, well. Oh, let's kill it. And now it worked. This is strange, or this looks strange really, because why would it not copy all this? Why would it not work? The trick is that version of the source code is actually running sequential, because you're just invoking copy, and if you have more than one client connecting, it will have to wait. The second guy will have to wait, the third one, and the fourth. Let's have a concurrent version of that. So that's the concurrent, and that's the non-concurrent. Can you see the difference? I find it quite nice that it's that easy to make your TCP listener just respond concurrently. I don't know if that's the same for you, but to me that's pretty awesome. In here, I can handle as many connections at the same time as my as many Go routines I would enable on a certain machine. So if you set the environment variable to 4, that would be 4. If you set it to something much higher than your CPU count, in theory, you would be able to handle more. However, with the caveat of you would pay the penalty of context switching and all the familiar stuff. But yes, you can. If I would set it to 4 with the max run procs, then yeah. WebSockets. How do you make WebSockets? That's it. It's WebSockets, because it's 2014. They are built in. If you want to do something with WebSockets, it's quite easy. I don't know how many lines an equivalent code in Java would be. Again, to me, for doing prototypes, for playing with REST services, or for playing with a modern web application, that's hard to beat. Question is, what looks bad in Go? Because I was just telling you what I like, and is everything so nice in there? This is how you do JSON. Unfortunately, I don't like it. I'm not a big fan of that. It looks a little bit too much, JAXB to me. But you can parse JSON, and you can convert that to your language types, and you have you have to put this meta information somewhere. Otherwise, the anonymous version of that would look really, really ugly, because you have maps of something unspecified mapping into something else unspecified. I would really like you to try and do something in Go tonight, or maybe tomorrow after you're rested. But do you have any questions? Anybody? Awesome.
So how is this code executed? Does it compile to binary code?
That's a very, very good question. Let's look. Let's kill this guy. Let's kill this guy. The question was how does the code get executed? Is it compiled to a binary? Yes. If I do a tree, I can scroll up a bit. This is what a library gets compiled into. If you look at main, it gets compiled to a as you can see, it's a Mac OS 64-bit executable, so it's a native format for your operating system. You can cross-compile, so you will end up having binaries that are specific, that are native to the platforms that you need. So it's you cannot just copy a binary from OS X to a Solaris box or to a Linux box. It will not work. But nothing stops you from compiling to multiple targets. And you've won the last beer. There is another question. Awesome.
So what happens when a 32 int variable overflows? Because in the square example, you were multiplying to 32 ints, and the result was 32 int as well. So if the ints are big enough, and if you multiply them, they can overflow and the return value.
Well,
does it just go round as in Java, or there's some
well,
error code?
it's an int, so your intuition is probably correct, but it's actually quite easy to check that. So that's. So we have a square, and square has an int 32. So how big should the number be? Let's say. Does it? It looks big enough. Go clean. Go build main. So yes, it overflows.
All right.
Now you can believe me and see what the result actually is.
Thanks.
And unfortunately, I don't have any more beer. So no, Go will not magically protect you against well, shooting yourself in the foot. But at least if you see this int 32, and you can, well, if you think that your variables have a high likelihood of overflowing, you might well give it some thought. If you just see an int.
Okay, I got a question. So, in real life, when would you actually use it? So for enterprise, we got Java. For tiny little spikes, we got, say, Python or something. When exactly should you use this one? Because I have no idea.
So the question, well, is when should you use Go? I can tell you that it's already being used in a lot of middleware, HTTP level middleware. Load balancers, routers. If you're doing microservices, you will probably need to write some software that will glue all the things together. If you've seen Tomek Lelek's presentation, they used a proxy that actually is rerouting things. You could, I would for sure start writing that in Go. I wouldn't do it in Java. If you need to do some native bits, communicate or use some existing C libraries, I would try to write my new code in Go. Because it's so much nicer than C, and I would expect to have it done much faster. I can tell you a story. We've had a very simple Java application that was basically serving things. It was well, fairly boring based on Spring. Well, everybody's default for doing web apps in Java. Run on Tomcat, so the whole binary was, let's say, 120 megabytes, and we wrote that into Go. The amount of lines that we got was 1/8 of the actual Go versus Java, not mentioning any XML. There was no XML for Go. And performance was so much better. We got over 3 orders of magnitude better performance. At first, of course, everybody was afraid, no, it's a different language, we can't read it. Have a look. Actually, I can read that. It was a very good use because that application was primarily working with HTTP traffic. If you're doing anything with HTTP traffic, if you're doing something with sockets, Go is perfect. If you're Docker, you've heard of Docker. That's written entirely in Go. Those are the use cases. I wouldn't write my business logic in Go because there are no generics or there are no templates. Where to do templates in Go, there is a script that allows you to generate some more code. Not the most awesome way to do, but low-level things. That to me that's perfect. Synchronizing, well, orchestrating. Yeah. Does your question feel answered?
So I've got one more question. You said that on eBay you've got some production code in Go. Could you tell what kind of code is it?
So there is a lot of glue code that we use to actually generate Scala code with. There is quite some middleware, some routers, some software written around load balancers. There is something that you can actually look at. If you look at well, UK's government, they are on GitHub. They do a lot of their new software they do it open source, so you can actually read some of their bits on GitHub, and that's actually what is powering Gov UK, a lot of their websites. And there is plenty of Go. There is again, HTTP mangling applications, that's in there. And that's something that you can look at because, well, to talk about internal eBay things, that would be quite difficult in here.
Ktoś jeszcze?
Anybody else? Szczepan, awesome.
Can you write tests for that code?
Of course you can write tests, but as I said, those bits were my favorite bits. Writing tests, it's not as awesome as I would say Spock is. So testing, well, it's a bit more basic, but you can write tests, and if I type go in here, there is go test run executing the test is already built in. We have this library that we took from go from here. So let's find, well, there are tests. So a test is just a bit of Go code that it doesn't have any special assertions or anything else. It just has to execute cleanly. And it's called _test, and that's it. There are no fancy things available, which coming from Java, well, there is no Mockito, unfortunately. Everybody loves Mockito, but it's not in there. It's pretty basic, but if you like writing tests, it actually forces you to write simpler code. At least it does it to me. I like that approach. I don't want to be needing things like power mock. That would be scary. In here I don't, most of the cases. Anybody else? Okay. Thank you everyone for being here. Thank you for staying that long.